All right, let's get right into it. Today, we are diving deep, and I mean deep, into the two massive climate engines that really call the shots for India's weather. We're talking about monsoons, droughts, floods, the whole deal. Now, if you're gearing up for the UPSC exams, you know that understanding El Niño and the Indian Ocean dipole isn't just for your geography paper. No, this is fundamental to India's economy, our food security, and even disaster management. So let's start with a real head-scratcher.
So check this out. We've all been taught El Niño is bad news for India's monsoon, right? So how do you explain this? Back in 1997, we had a monster El Niño, one of the strongest on record. But India's monsoon was pretty much normal. Then, fast forward to 2002, a much weaker, moderate El Niño pops up, and boom, we get hit with a devastating drought. What gives? There's clearly a missing piece to the puzzle here, and by the time we're done, you're going to know exactly what it is.
Here's how we're going to tackle this. First, we'll look at the big global driver, the one happening over in the Pacific. Then, we'll explore its alter ego, La Niña. After that, we'll bring it closer to home and talk about the major player in our own backyard, the Indian Ocean. We'll tie it all together to see how it impacts India's weather, and then, the best part, we'll see how you can use all this to absolutely nail your UPSC questions.
Okay, first stop, the vast Pacific Ocean. We need to get a handle on the main character in this global climate story, the one and only El Niño. So what is El Niño, really? Well, the name means the little boy in Spanish, because it tends to show up around Christmas time off the coast of South America. But there's nothing little about its impact. At its heart, it's just this. A huge patch of ocean surface water off the coast of Peru and Ecuador gets unusually warm. And this patch of warm water is so massive and so influential that it literally throws a wrench into normal weather patterns all around the world. So how does this whole thing kick off? Think of it like a chain reaction. See, normally you have these steady winds called trade winds blowing from east to west across the Pacific. But during an El Niño, these winds weaken. They just lose their punch. This allows that gigantic pool of warm surface water that's usually piled up in the west to kind of slosh back eastward all the way to South America. Now, this warm water is like a heavy blanket, and it pushes down the colder water below it. And this is the critical part. It stops the process of upwelling, where cold, nutrient-rich water from the deep ocean rises to the surface. And that has massive consequences.
But here's the thing. El Niño is only one side of the coin. It's got an opposite, a polar opposite, that flips the whole system on its head. Let's talk about its counterpart, La Niña.
And this image just shows it perfectly. On the left, you've got El Niño. Look at that angry red blob of warm water parked in the eastern Pacific. Now look to the right. That's La Niña. It's the complete inverse. You see that deep blue band of super cold water in the exact same spot? It's like a giant climate switch has been flipped.
So let's just boil it down. El Niño, trade winds get lazy, warm water shifts east, and that usually means a weaker monsoon for India. La Niña, the trade winds go into overdrive, you get cold water in the east, and that tends to give India's monsoon a major boost. Simple as that. So, the official definition for La Niña, or the little girl, is this cooling phase. And for us in India, this is generally great news. It often means we get more than enough rain during the monsoon, and sometimes even colder winters.
And when you put these two together, the warm El Niño and the cold La Niña, you get the full picture. The scientific name for this whole back-and-forth cycle is ENSO. That stands for the El Niño Southern Oscillation. It's just one big, powerful seesawing system that rocks back and forth in the Pacific.
Now, if ENSO was the only thing we had to worry about, predicting India's monsoon would be a piece of cake. El Niño, bad monsoon. La Niña, good monsoon. But it's just not that simple. We need to introduce the other major player in this game, India's own regional climate powerhouse. And this quote brings us right back to our mystery. As the source says, not all El Niño years led to a drought in India. Why? Because there's another system right in our own neighborhood that can step in and change the game completely. And that system is the Indian Ocean Dipole, or IOD. You can think of it as the Indian Niño. It's another climate seesaw, but this one happens entirely within the Indian Ocean. It's all about the temperature difference between the western side, near us in the Arabian Sea, and the eastern side, down by Indonesia. So the IOD has two modes. A positive IOD is when our side, the Arabian Sea, gets warmer than the eastern side. This is great for India because it helps pull moisture towards us and boost the monsoon. And here it is, the answer to our puzzle.
A strong positive IOD can actually fight back against El Niño and save our monsoon. That's exactly what happened in 1997. A negative IOD, on the other hand, does the opposite. It makes a bad situation even worse.
Okay, so we've covered the big theories. Now let's connect the dots and see what this actually means for the weather we experience here in India, from floods and droughts to cyclones.
You know, the reach of a powerful El Niño is just staggering. It can trigger terrible droughts here and in places like Indonesia and Australia, but at the exact same time, it's causing massive floods in Peru and California. And because it shuts down that upwelling process, the fishing industry off South America gets completely wrecked. It's a total reorganization of the planet's weather. And the IOD has its own tricks up its sleeve, especially when it comes to cyclones. During a positive IOD, that warmer Arabian Sea becomes a hotspot for cyclones. We tend to see more of them, and they can be stronger. In a negative IOD, the action shifts over to the Bay of Bengal. For anyone involved in disaster management, knowing this is absolutely critical.
All right, so you've got the science down. Fantastic. But let's get practical. How does UPSC actually test you on this stuff? How do you turn this knowledge into marks?
Okay, pop quiz time. This is a real question from the 2017 prelims. Have a quick read. Statement 1 is about where the IOD happens. Statement 2 is about whether it can affect El Niño. Based on everything we've just talked about, what do you think? Which one is correct?
And the answer is 2 only. Did you get it? Statement 1 is a classic UPSC trap. It tries to confuse you by mixing up the Indian and Pacific Oceans. But you know better. The IOD is an Indian Ocean-only event. Statement 2, well, that's the whole point of our discussion, isn't it? The IOD can absolutely influence and sometimes even cancel out El Niño's impact. See? It's a direct test of these concepts.
And this isn't just for prelims. For the mains exam, this knowledge becomes even more important. When you get questions about urban flooding or cloudbursts or coastal erosion, you can't give a complete answer without talking about the big picture climate drivers like ENSO and the IOD that are making these extreme events more frequent. Because at the end of the day, understanding these twin engines is about so much more than just passing an exam. For anyone who wants to be an administrator in India, this is foundational knowledge. It's the key to making smart decisions about everything from managing our water resources to planning our agriculture and building a nation that's ready for the climate challenges ahead. So, here's a thought to leave you with. If you were the policymaker, how would you use these climate forecasts to safeguard India's future?